go. Welcome, everybody, to Contemporary Issues on May the 9th. Nice to have you here on Mother's Day. And we are going to talk today about geology on the Front Range. Learn a little bit about history and rocks, and looking forward to this. But before we do our usual announcements, please mute yourself in the lower left corner of your screen. And we are recording this today for future playback. And please be kind to our speaker, Ron. He will do a wonderful job with this topic, and we want to give him the grace to do that. So, anything else going on, folks? We were just talking about traveling and opening up of society and restaurants from COVID here. And anything else going on in the news we want to talk about for a minute before we start? Anything to share? There are still some openings at St. Andrew for the May 23rd opening service at 9 a.m. They say if there are a few more openings for the limited seating, if people want to sign up. So Vicki and I will be going to that. We'll report back to you on what it's like to be in the building again.
Steve, I tried to sign up and I was told that it was full.
Oh, okay. Maybe it is now, but there, as of a day or so ago, there were a few openings, they said. But you might check back in case anybody
Yeah,
drops off. They have a waiting
okay.
list,
I'll try
too.
that.
But uh, they are trying to get back to normal. Okay, with that, let me share with you my rock collection. This is my one rock I have in my rock collection. It says Steve, and on the other side it says, "Be still and know that I am God." Somebody gave this to me from St. Andrew in one of our previous uh, classes at St. Andrew. I need to expand my rock collection. Ron has a wonderful rock collection of all different colors and hot rocks, radioactive rocks, and all kinds that show what God created on this earth. Okay, Ron, take it away.
Alrighty. Well, this talk was kind of inspired by Steve, and that Doug Moen, Steve Vasca, and myself took a little hike on a semi-rainy, right after a rainy weekend, and we went to Dinosaur Ridge. And that picture down there on the lower right is a picture taken in front of some of the dinosaur prints that they had sprinkled with charcoal the day that we were there. So that was a lot of fun. But if you've been to the Denver Museum of Natural History, you'll probably recognize that classic painting off to the right. And then there's a picture there in the upper right of this slide showing oceanic sandstone prints of the seashore in Colorado many, many years ago. All right. Well, if you're a big fan of geology or you just want to learn a little more about what's in the neighborhood in terms of rocks, 3 books I recommend. One called Geology Underfoot that you see there. And if you're going to go driving around Colorado, you ought to put this book in your car, Roadside Geology of Colorado. Just about any route you take around the state, it will take you through some of the geologic features you'll see on the way. And then maybe the best book of all is this one right here. It's been awarded many stamps and recommendation, and it's called Messages in Stone, Colorado's Colorful Geology, loaded with pictures. You don't have to be a geology PhD to understand this or appreciate it. Filled with pictures, a good book to give even the grandkids to learn a little bit of geology. Okay, speaking of things you want to buy, one of the best posters I know of is one called Heroes of Life. You get it on Amazon, but in one giant screen, it shows the history of the Earth. It takes you through all the different eras and times. And the Earth, of course, is about 4.65 billion years old, whereas the universe is more like close to 14 billion years old. But how did things get started? Well, of course, one of the earliest types of life is the prokaryotic cells. Those are cells that don't have an inner nucleus. And the prokaryotic cells show up about 0.7 billion years after the formation of the Earth. And then if we hang around another 1.3 billion years to the 2 billion year mark, we get to the eukaryotic cells, which have not only an outside cell membrane, but an inner cell nucleus with DNA strands and a more complex nucleus. So life starts moving along via evolution pretty early. Here's a timeline of the Earth. Again, the Earth was formed about 4.65 billion years ago. And the earliest bacterial fossils we get show up about 0.7 billion years into Earth's history. The oldest rocks we see that are at the surface of the Earth are less than 1 billion years into the Earth's history. And as we start moving along this timeline, very slowly, we start working up in life complexity. At the 3 billion years before the present, we start seeing the archaeobacteria. In other words, we start seeing a little more complex bacteria show up. And then the single cell eukaryotes, those are the bacteria that have a nucleus, show up just before 2 billion years ago. And then we end up with multicell eukaryotes, higher algae, and we move along, and we don't see life as we kind of know it with fish and land-based plants show up until the Cambrian explosion, as they call it. It's not an explosion of geology, it's an explosion of life. And that happens about 500 million years ago. So we can see where life is, as we know it, other than bacteria and simple single cell, multi-cell bacteria, really occurs in the last 500 million years. And if we put the age of the Earth into a calendar year, as is done in the Neil deGrasse Tyson and Carl Sagan presentations of Cosmos, which I highly recommend, if we put the life of the Earth into one calendar year, our sun doesn't show up until August 31st. This is since the Big Bang. This isn't, if we put the life of the universe into it 1 year, we get this timetable. And the small galaxies show up around January 13th. Our sun shows up about August 31st. The really simple life, single cell bacteria and stuff show up in the fall. The human race doesn't show up until December 31st, last day of the year, at about 9:45. That's late. The first writings in human history, about 11:49. Jesus doesn't show up until 5 seconds before midnight. And so on the history of the Earth, the mammals and the human life are very, very late in the history of the universe and the history of Earth. Okay, looking at the Earth, we cut a cross section. We've got an inner core of solid iron, and then we've got an outer core that's liquid and lots of nickel, and that extends from about 3,100 miles out to about 8 deep. This is miles deep, 3,100 miles deep to 1,800 miles deep. Then we have the mantle, and then finally the thin crust. There's a comic book, Cave Carson Inside the Earth. Okay, if we look again at the cross section of the Earth, we have the inner and the outer core, and we've got a huge molten area of aqueous molten rock, and it has convection currents flowing around within it. It's very thick. It's the thickest part of the Earth. It's molten. It's aqueous. It's got a lot of iron. And thank goodness we have that, because this aqueous, molten, iron-rich lava that's flowing around in there produces a strong magnetic field. And that strong magnetic field, which we see in this picture on the right, gives the Earth its protective magnetic field. And that protects us from solar burst and a lot of solar radiation coming off the sun, and really makes life possible on Earth. That's one of the problems with Matt Damon going out to Mars. Mars does not have a molten core like that. It doesn't have a protective magnetic field or a protective atmosphere, and gets bombarded with heavy radiation and solar bombardment that is detrimental to life. So that's part of our Earth. Okay. Interestingly enough, it wasn't until about 1960 that they really nailed down the fact that the Earth has kind of floating plates on it. And that although this concept was first proposed around 1920 by an early scientist, it wasn't until the 60s that the full scientific community and hard evidence came in, and there was conclusive evidence that yes, the Earth is a bunch of floating plates on the crust that move and drift and collide and pull apart. And if we go back to what they call the Permian period of Earth's history, there was one giant continent that was combined. It's called Pangaea. And it started to split, and it took millions of years to split. And this diagram here shows the plates of the Earth that were all sort of floating on the surface on this hot liquid magma, started splitting, drifting, and separating into the continents that we know today. And we can see even in the time of the dinosaurs, the Jurassic period, still here's North America, and it's connected pretty much to the Russian, Asian, Siberian continent. And we can see before that, if we go back here to the Pangaea, we see that how we were connected to Brazil and Africa, and that was all combined together. Time does a funny thing. We live such short lifetimes as humans. To give you an example, if you get a 1 inch per year drift rate of a continent, you say 1 inch a year, that's nothing. In my lifetime, maybe the Earth will drift, or one of the continents will drift 80 inches. You say, yeah, that's nothing. But if you keep up a 1 inch per year drift rate for 100 million years, or a tenth of a billion years, you'll move over 1,500 miles. So that shows what snail's pace movement can do when you start multiplying it by numbers like 1 billion or 2 billion, and certainly in the case of the Earth, 4 billion. And so again, think of a supercontinent, Pangaea, the split of the continents, and then the continents as we have today. There
Hey,
was a
Ron,
movie. Go ahead. Go
can I
ahead.
ask a question? Do you mind if we ask questions while
Sure,
you're
please
talking?
do.
Are there any other planets we know of that have floating plates like this? Or are we the only one?
I don't think we know enough about Venus to be sure. Venus is a possibility, and but certainly the Earth is the only one we have pretty concise and definitive assurance that we have floating plates. We know
And
Mars doesn't, and then of course once you're out beyond Mars to the gas giants, they are mainly gaseous planets like
just
Saturn.
another question, if I could, while it's in my mind. Are the other solid planets, do they have an iron core like Earth does?
We don't think so.
Okay.
So we've got some very special conditions with that molten iron moving around, giving us that protective layer.
Yeah, thank
Kind of
you.
like the Starship Enterprise with a protective shield.
Okay.
Okay. There was a movie in the late 50s called The Crack in the World. And this was before they knew about the plates real well. And they thought the Earth was like a piece of lumber, which I've got down here. And the movie showed a giant crack that propagated and was working its way around the Earth. And they were trying to prevent the crack from propagating and splitting the Earth in two.
We'll have to rent that.
Yeah, pretty good movie.
Never seen that.
Pretty good movie. Okay. So if you go by that poster I recommend, and I do recommend it, it shows, if you're a geologist, they break the Earth into a lot of different sub zones in terms of time. The biggest block of time they call is an era. And there's 4 major eras. There's the Precambrian era, Paleozoic era, the Mesozoic era, and the Cenozoic era. We're in the latest one, the Cenozoic era, and that era began about 65 million years ago. And again, this map, it gets into a lot of complication. We further break eras into periods, and you've probably heard of a lot of those periods: the Jurassic period, the Triassic period, the Cretaceous, the Permian, the Pennsylvania, and then they further break periods into epochs. And then you can map these time eras. Here's time going from 4.6 billion years up to the present, the 4 big eras. And then we have, geologic-wise, the many formations that appear in different parts of the Earth up through those periods of time. So geology gets pretty complex. A quick way to remember it is the Paleozoic era was dominated by sea life. The Mesozoic era was the age of the reptiles, and we're in the Cenozoic era, the last 65 million years, and that is a mammal dominated time of life. Again, if you look at
I have a question. Can you go back to that other slide? Did you? How could you relate the great oxidation event in here, where you said so much life occurred in the last 500,000 years? Did you any reading about how there wasn't an atmosphere and it was so hot on the Earth until the last 500,000 years?
okay, if you have a plot on the x-axis and show the time life of the Earth, you will see dramatic changes in the content of the atmosphere in terms of whether it was CO2 or oxygen or other sulfur gases, and it changes dramatically. There were many times in the period of the Earth where the atmospheric composition wasn't such that mammalian life or even reptilian life could have taken hold. You really need pretty good concentrations of oxygen in the atmosphere to support reptilian and mammalian life. But yeah, that's a subject all its own, the composition of the atmosphere. Okay, again, who ruled the Earth? What dynasty? It wasn't the Tudors or the Edwards or whatever those English family were. The dynasty that really ruled the Earth for the longest period of time, hands down, was the dinosaurs. 235 million year reign. So they've dominated the history of the world in terms of life form. And by the way, the separating line between the dinosaur age and the mammalian age, which moved us into the Cenozoic era, was the great meteorite strike that happened down on the Yucatan Peninsula. Here's a map. Giant meteorite hit the Earth. threw up this massive cloud of debris, snuffed out the sunlight coming to the Earth to a great degree, and basically wiped out the dinosaurs in a matter of months. And for that matter, wiped out a lot of other life forms. You can see evidence of this great wipeout by looking for the iridium. That's an element called iridium. They call it the KT boundary. The KT boundary, one of the first discoveries of it was right here in the Greater Denver area, in the area around Golden on the mesas there. Okay, so there's been.
Can you see that as you're driving?
You can go up to the North and South Table Mountains and see evidence where it is. I'm not sure as you can do it driving. You can certainly see it near the New Mexico Colorado border. As they cut the interstate through. There's some textbook areas there where you can see where the hit.
Where was that? Where is that, Ron? Where is that?
One of the most exposed places is where I-25 drops down the southern Colorado border and goes into New Mexico, Raton Pass. There's a lot of geology books that have pictures of the iridium layer there at the Raton Pass. There's other places now in Colorado where you can see it, and I'll have to dig up some of those and let the class know.
Road trip.
Road trip. But
We're in.
looking at the major extinctions of life, there's about 5 time periods where there were major extinctions. We're actually in one now, and I'll talk about that in a second. But the one that occurred with the Great Meteorite Strike is on the Cretaceous Tertiary period boundary, 65 million years ago, and it wiped out about 75% of the species of life. There's been other ones in the history of the Earth. There was a great extermination between the Permian and the Triassic era, and that wiped out 96% of the marine species. That means life in the seas, and 70% of the land species. And I put a yellow star on that one because the scientists are still doing studies to figure out exactly what caused it. Was it a meteorite? Was it a tremendous change in ocean levels, or a combination of those factors? But that's another thing, sub-study is the big wipeouts. Again, there's a book out now called The Sixth Extinction. They're calling us the Anthropogenic Age because human beings are wiping out a lot of life. And to quote Pogo, we have met the enemy and he is us. We're the cause of this 6th extinction that's going on right now. There's a review of the mass extinctions and what caused them. I won't go into that anymore other than to say a lot of interesting studies. Okay, let's do a quick run through a little bit of geology and then we'll jump into some of the front range things. In these giant batholiths, or pools of molten lava deep in the earth, we sometimes end up with pathways of molten lava heading for the surface of the earth. Those are called dikes. And then as the dikes work their way up through horizontal layers, often sedimentary layers, they spread out into what we call sills. So those are dikes and sills of metamorphic rock. Here's a picture of a location. You can see this creamy dike here where igneous rock has come up from deep in the earth and worked its way towards the surface. As it's penetrated sedimentary layers, we can see where the hot lava flow has seeped along the boundaries between the sedimentary layers.
Is that at Black Canyon?
And this picture isn't from Black Canyon, but it's a Black Canyon-like area. Black Canyon, the Painted Wall, is probably the most spectacular area in Colorado to see some of these kinds of dikes and sills of igneous rock. We, of course, have igneous rock, which is the molten hot stuff. There's sedimentary rock, which is like it sounds. It's sediment that has been settled, and then metamorphic rock.
You know, Ron, I wonder if you could do something after this presentation. You're presenting like certain areas in the country, especially in Colorado, where some of this stuff is. And I don't know if anybody else is interested, but I love to know where some of these places are to go visit them. And
Okay. Yeah, go buy those 2 books. That's what I'd recommend.
When you're finished, you'll have to put the 2 books back up
yeah,
again.
you
I
can
will
do
do
that.
that.
Thanks.
And then finally, metamorphic rock. Metamorphic is really not a kind of rock in itself. It's one of the 2 above. It's either an igneous rock or a sedimentary type rock that has been changed by the environment, either compression, heat, erosion, etc. All righty, there's again those, you can really get into studying the eras and the epochs and all the things that change. These charts are in some of the books that show distinct things they know what happened in certain areas. Won't go into those. Let's do a little bit of basic geology again. These plates on the surface of the Earth are usually moving, and they can either be moving apart, we call those divergent plates. The more interesting one is where they collide, they're coming together, convergent plates. And then if they're sliding horizontally, we call those transform or shear plates. Those are the kind of 3 types of plate collision we have. And
Earthquakes.
we often get earthquakes, particularly if those collisions happen quickly or release their energy in sudden burst. When crust meets, here's a crust of the Earth, here's some ocean, here's some oceanic crust, and here's a collision going on, a convergent plate collision, where an oceanic crust, like the Pacific plate, is colliding with maybe, say, the North American plate, and the heavy ocean crust, which is heavier than continental crust, gets pushed under. And that's an important word, they call that a subduction zone. That's where the lower layer of the cake gets pushed under the upper layer of the cake. When that happens, the crust that gets subducted or pushed under gets heated. It releases often magma that escapes and forms a volcanic ring where the subduction is occurring. There's a lot of subduction going on. You've probably heard of the ring of fire around the Pacific plate, and that's where the Pacific plate is colliding with a lot of others and creating these subduction zones. It's diving under the continental plates and creating these volcanic areas.
Is that Hawaii?
And Hawaii is a place on the Earth where there's a plate moving across a hot spot in the magma and creating upswells. When they did oceanic surveys just before the Cold War and after World War II, they found there was a tremendous ridge in the center of the Atlantic Ocean called the Mid-Atlantic Ocean Ridge. And it's a giant volcanic ridge going up through the ocean bottom in the Atlantic. And the next picture shows what's happening. Here's this Mid-Atlantic Ridge where we have a lot of hot magma and even lava coming up through vents in that Mid-Atlantic Ridge. And it's literally growing islands out in the Mid-Atlantic that haven't emerged from this above the surface yet. Okay, again, there's a picture of a subduction zone, and we can also have subduction zones occurring where there are land plates hitting together. And a good example of that was when there was a war between Wyoming and Colorado. Not a war, but a geologic collision. It was a plate up there by Wyoming that came down, and it collided with Colorado, dove under it, and formed a Colorado volcanic arc. This was about 1,800 million or 1.8 billion years ago. And there's been lots of plate collisions. Okay, there's another picture of that, and it shows you get a lot of wild things happening where you have these plate collisions. Okay. We also have faults in the Earth, and here's an example of some faults. Here's faults that are pulling apart, faults that are colliding, and faults that are slipping. We not only have faults, which are these more vertically oriented cracks, and then we have these joints that are more horizontally oriented. And they're all over the place if you look at a geological map. Okay. Whoops, I'm going the wrong way. There we go. Too bad Steve Horst isn't along, because where we get a block of rock where there's a fault on both sides, if it sinks, they call that a graben. And if this block gets pushed up, and I don't have that in a picture, it's called a Horst. So I joked with Steve Horst. I said, you're a block of rock that's been lifted up high. There's an example of a fault. You can see where there used to be, here was it looks like a sill, an igneous rock layer, and it used to join this one right over here, but there's a fault in between, and this part has come down, this part has gone up, and there's an example where a fault has shifted and created this discontinuity. Okay, we also have, of course, folds and dips in the Earth. This type, where there's a protuberance upward, they call that an anticline. Where there's a dip like this, they call that a syncline. Here's an example in Colorado where you have some anticlines and synclines, like a wave of rock. And, also, geologists talk about dip and strike to talk about the angles of layers of rock that are tipped up or tipped in certain directions. And we've mentioned sedimentary rock, which is abundant in Colorado. And there's a panorama of Green Mountain, and we'll talk about that in just a moment. We also have in rock, particularly in sedimentary rock, we often have something we call unconformities. That's where something has happened, where there's been a layer of rock deposited, and then something happened in geological history to wash or wipe away a layer of rock. And then deposition started again maybe a billion years later, after a missing layer was washed out. So we call those missing layers unconformities. So we don't always have pure continuity as we move up through layers of rock. There are occasions where we have unconformities. For those that have visited Grand Canyon and have driven up through the Grand Staircase Escalante National Park, here's an example of Grand Canyon way down here with Old Rock. And as you drive toward Colorado, you can see as you're working your way up through geological time, and you can just see all the many, many different rock layers as you work your way towards Zion National Park, toward Arches, towards the Colorado Western areas. A lot of layers of rock. And if you want to go uranium hunting, you want to look for this Chinaroope layer and the Shinle layer. For those of you like me that are uranium.
Tell us we're not doing
mineral
that.
people. Yeah, we're not doing that this week. Okay, let's get to the Front Range and move a little more quickly here. The Front Range has been uplifted a minimum of 21,000 feet. We've got about 7,000 feet of rock beneath us, below sea level. And then we've got 14,000 feet of rock above sea level. So add all those layers together in the Denver area, and we've got over 21,000 feet of rock layers. Again, about 7,000 feet below us and about 14,000 feet above us. Actually, I've got to adjust that for the fact that we're sitting 5,000 feet above sea level. So most of it's above us. Okay, as we go north up Highway 93 out of Golden, here's Highway 93 basically comes up through here. There's the brewery, the Coors Brewery. There's North Table Mountain, South Table Mountain. There was a magma or volcanic dike that came up right pretty close to where Rocky Flats was, a little closer to the mountains. And it had at least 3 major lava flows that can be seen in the pancake layers there along North Table Mountain. North Table Mountain is a triple layer pancake for those of you that want to hike it. North and South Table Mountain also had these lava layers on them, and the basalt of the lava layer formed a protective hard lining layer along some of the valleys where they flowed, and that protected some of the geologic areas from erosion. We look at the top of North and South Table Mountain. They've got a hard layer of protective basalt on top of them that has protected them from eroding away. But if we just move south of North and South Table Mountain, we get down to what I call the Green Mountain sediment pile. No, this was not formed by a giant cat that used it as a litter box, but it is literally a sediment pile of kind of alluvium, as we called it, or washed away eroded mountain stuff. If you hike it, you'll see it's got a lot of round rocks, a lot of loose gravel, a lot of gravel, and it's kind of a washout pile from the Rocky Mountains. And that's bad news if you want to try to build a house. And you won't find any houses built up there, simply because it's loose gravel, kitty litter. It's going to slide and slip, and it's just not meant for building on. Then there's good old Dinosaur Ridge. We had melting glaciers pouring water down from the north, and there's a picture of a melting glacier water channel, and it piled up some dinosaur bones, particularly on the curves in the floodplain of the Ocean Creek, and left the footprints that we find. Okay, how are we doing on time? I need to quit yakking. Here's a cut out of the book, Roadside Geology of Colorado. And we can see just coming up from Chatfield, which is down here, along Highway 285 going up to Golden, all the geologic zones we're cutting through. Dinosaur Ridge. And we can see a huge fault that goes up through there. They call the Golden Fault. Although I don't think it's very active right now. But these red lines are faults, cracks in the earth, shall we call them, that fall up along this line. I love to hike along here because I know as Steve and Doug and I walked across that ridge, you can walk just literally there a few hundred yards and move from one rock layer formation in one era of life over to another by just walking a few hundred yards up and over the ridge. By the way, the abrupt mountain uptake of the Front Range here was caused by a collision of the North American plate and the Pacific plate. So that's a good one to look at. We also have events called orogenies. No, I didn't say erogenous, I said orogeny. Were other events that have occurred in addition to these plate collisions. There was another plate movement, a different collision. It's like a dodgem thing. The plates are moving around, so we end up with different collisions. You got to get the right collision correlated to the right mountain formation. There was another collision called the Laramide orogeny. It occurred about 67 million years ago, and that pushed, you can see that golden fault right here, and it pushed a lot of the Rocky Mountains up over the plate area along Denver and gave us a lot of that really aesthetic rock uprisings that we see by the Flatirons and in Roxborough State Park and other places. So a lot of that was caused by the Laramide orogenies. So you definitely want to study those orogenies. There's another cross-section picture showing all the fantastic stuff that's been going on right along the Front Range there, with all these different rock formations, the collisions of plates, the different orogenies, and this book actually gives stops to stop and look at some of these places. There's that KT boundary, which is the iridium layer, where we have evidence of the iridium element thrown out by that meteoritic collision. Again, there's another picture of some of those rock formations. And if we extend this diagram below the one up on top here and show it all the way over to the Eisenhower Tunnel and Dillon, we can see some of the other major faults, and we can also see the many different kinds of rock that we work our way through that represent different eras of history. Up there in Rocky Mountain National Park, we also had glaciers play a role in the formation of the Front Range. And right there in the Moraine Park area, there's a big glacier came scouring down in the valley. It scoured the rock. You can see the scour marks. And it formed a moraine on the north and the south boundary of the glacier. So glaciers also played a role. We also have something in Colorado that you don't find in most other states, and that's rock glaciers. And this is one on Mount Sofree. Does anybody know where Mount Sofris or Mount Sofree is?
Not up there by Marble.
If you've driven from Glenwood Canyon up, or from Glenwood up to Aspen, you've gone up the river valley. What do they call it? The Crystal River Valley?
Yeah.
Or no?
St. Vrain.
Or up, and anyway, the valley it goes between Glenwood and Aspen. And Mount Sofree is the magnificent mountain on the right before you get to Aspen, and it has a magnificent rock glacier of crumpled rock that's getting pushed down Mount Sofris or Mount Sofree by rock formation. So again, you can really get into those maps. We won't do any more of that. Really dig into the time charts. Here's a blow up of the geologic time chart for just the Cenozoic era in Colorado, and we can see that Laramide orogeny. It occurred 72 to 40 million years ago, and it talks about some of the key things that have happened just in the last 65 million years. A clockwise rotation of the Colorado Plateau, erosion of the mountains. Colorado is an exciting place if you're a rock nut. And then there's some of the Precambrian formations, and even in El Dorado Canyon, you can see some magnificent Precambrian rocks. And of course, you can also see them in Black Canyon, and even some, I believe, in Clear Canyon, special locations. So it's heaven on earth for a rock hound if you live in Colorado here. Okay, well, I've talked a lot. Let's open it up for some questions and thoughts from the gang here. I don't have all the answers. I am not a geologist by trade or profession. I've taken some classes, but that doesn't make me a world expert. But between my curiosity and the books I've read and my rock collection, I've learned a good bit. So,
Ron, I have a question about global warming and the climate, what we said in was it fifth or sixth extinction that's going on right now? So imagine it's affecting the formations of the rock. Is that causing extinctions and stuff? But what does it do to what you just showed us with the movement of the rocks and the plates and the, faults, and is that affecting that too? Does that?
I don't think climate change is, it's going to change the amount of erosion because of water flow and water deposition, and water seeping into places and forming caverns. But no, the vast majority, the totality of the climate change is going to play its havoc upon our atmosphere, our ocean, and our surface soils. That's where it's going to really wreak havoc relatively in a hurry. Old Mother Earth with her deep geology is going to be very slow to react to climate change. Let's put a couple of these books up too. There's one I recommend. I think it's a marvelous thing to buy. You'll see it at bookstores, and as you travel Colorado, at visitor stations and whatever. So that's a great one. It's a great one to give as a gift to grandkids, or even to put on your dining room table and study. And it's filled with pictures. You don't have to be a bookworm to enjoy it.
Thank you, Ron. May I ask a question?
Sure.
Yeah, outstanding. So helpful, so informative. Thank you. Kind of a silly question in a way, but are rocks harmless? The reason I ask that, having lived in Southwest Colorado and all the uranium mining, there are some health issues when you get around those mines and the tailings and so forth. I also think of Rocky Flats and the radioactivity and even meteorites that have come down to Earth. Are in fact rocks harmless, essentially, or are there some rocks we ought to be aware of?
The answer is, for the most part, rocks are pretty harmless, but yes, there are places where you better be careful. If you go to Zimbabwe in Africa, there are massive uranium deposits that have some very, very hot rocks. I've got a rock from the Ike Nixon mine that's about the size of my fist, and you want to keep that away from people. It's quite radioactive. It's not going to harm you immediately, but if you put it under your pillow and if you keep radioactive rocks with significant radioactive intensity near you for long periods of time, they can do you harm. Likewise, other rocks, rocks with mercury. We know mercury vapors are particularly bad for us. And certainly rocks that contain large amounts of arsenic or some other substance. You don't want to go licking and chewing on rocks of certain character. A lot of metals, heavy metals and stuff, if ingested, are very bad for you. Certainly the ones with arsenic or even a lot of other heavy metals that you don't want to ingest. There's a joke at School of Mines. They call Geology 101 rock licking 101. And they actually have some of the students there touch their tongue to rock. And that's okay for most rocks, but you wouldn't want to do it for uranium rocks, arsenic rocks, and some of the other ones. in general, you're pretty safe, but careful with the uranium rocks, and also relative to meteorites. Meteorites are overwhelmingly harmless relative to their content. Almost all of them are iron and nickel. Some of them contain a little bit of iridium or something, but for the most part, they're almost uniformly safe.
So Gene, don't be licking any rocks now.
A rock licker, yes.
Hey, Ron, how do people reconcile it if they think that the Bible says the earth is only 6,000 years old? What would they say to your presentation about billions of years?
They have, I've come to a point where I'm not afraid of truth. And I want to conform my life to truth, not myths. And I'm sorry
Yeah.
to say, but the biblical story on the creation, it's got some aspects that relate to geology, but you certainly cannot begin to claim that the Earth is only 6,000 years old. I mean, there's
The Bible was never meant to be
overpowering.
Bible never meant to be a science book
Yeah.
anyway, as we know. But some people add up the generations in there and think it's 6,000 years, and so they think that that's when the Earth was formed.
Mhm.
Who knows?
Yeah. Yeah, if you want to have a lot of fun, get this book, Roadside Geology of Colorado. This book series covers a lot of the states. There's a roadside geology of Montana, Utah, even Ohio and Indiana. But as you drive along and you're on a road trip, you can buy one of these books and look as you drive a route and see what there is to see, and it'll give you a little geology history and pictures of the routes you're going to take. So I highly recommend you add that book to your pop it in your car with your travel map.
You know, Ron, I'd love to go on a field trip with you. You should do that. We should do like a contemporary issues field trip to Dinosaur Ridge or something. And you could talk us through what we're seeing.
Okay.
That'd be fun. Ron, do we have any active faults in Colorado moving? Any tiny earthquakes? It's nobody's fault, but just wondered.
This book, Messages in Stone, has a chapter on that. The answer is there's nothing that's super active, but it does show the earthquakes in Colorado that have occurred in the last 300 years. And there are a couple of them in mountainous areas. I'd have to say we're pretty darn safe out on the plains and the Front Range. There are a few areas in the mountains where there is the potential for an earthquake, although the odds are not nearly as high as they are in places like the San Andreas Fault. So yes, there is some earthquake potential in Colorado along a few of the faults in the Rockies, but it's not a real high risk number.
Rock and roll.
You're on a roll.
You know, one of the things that strikes me is how recent our knowledge is of all this. That it wasn't until I was a teenager that they were talking about the plates that we now know is true. And I grew up in Arizona, and my dad one day, he was a lawyer, and a client gave him a rock of uranium. And he brought it home and gave it to me, and I had it on my shelf for any number of years, and nobody ever told me that I shouldn't do that.
That's where the glow comes from.
Yeah.
Yeah. Well, actually, you'll be quite okay as long as you keep a good 8-10 feet distance. Don't put it under your bed, under your pillow. Don't lick it.
Tell them ours is out. Shit.
Yeah, I've got some uranium rocks which I keep out in the shed. Yeah.
I kept mine in my bedroom.
You know,
a small one, like the size of a pea or a marble. if kept, 5 feet away from you, you're going to be fine. And you're not going to be in trouble if you even keep it in your pocket for, half a day or something. It's prolonged exposure.
Back to your question, Steve, about the spiritual and religious significance of all of this. Roxborough State Park, such a gorgeous, beautiful place, as so many of us know. What a wonderful place for a spiritual retreat or for a class from St. Andrews to utilize that sometime. I mean, it's hard not to be elevated and feel God's Spirit around you when you're in that beautiful setting with those beautiful red rocks. So, I mean, the way Ron was presenting this, certainly God's creation and its beauty and majesty certainly uplifts, play on words, uplifts us all as we reflect on all this. Again, thank you.
Yeah, I think too, there is a theologic aspect to it. There's lots of things in the Bible about mountains and rocks, and this helps us to have a little more background on that. So, kind of an indirect connection. We're about out of time. Ron, you got anything more?
No,
To
other
talk
than
about?
thanks for listening, everybody, and hopefully your interest has been pricked and learned a few things this morning.
It's a great presentation.
Thank you, Ron.
I
Okay.
like Bob's suggestion too. We might have a class field day for those who want to join out to Dinosaur Ridge, because Ron and Doug and I had a great time there a month or so ago. There's so many dinosaur tracks out there. It's just amazing to see. It's quite educational.
Yeah.
Okay, thank you, Ron, so much. You put a lot of work into that. We appreciate it.
Okay.
Great as
Thank you,
usual.
Ron.
Thanks
Thank you,
to
Ron. Thanks very much.
everybody. Next week, I'm going to do a presentation on the theology of the Peanuts comic strip.
Okay.
And we will see what all messages are in there. There's quite a bit, actually. It'll be fun. Okay, take care, everybody. See you
Thank
next
you.
week.
Bye.
Thanks, Ron. Bye.
Bye-bye.